Hello YouTube, this is Stan from Stanny G Tech, and today is a second lecture on topic of basics of computer programming in C. And as a recap, in the first lecture, we were covering about computer components and mainly RAM and CPU. We were talking about how are they responsible for storing information and processing it in a program. Secondly, we got introduced to some terminology there, and I showed you what the Visual Studio looks like. And then we did a small little project, and I showed you how the code actually works. So in this class, we'll be continuing talking about basics, and so some of the topics that we're going to talk about include tracing code. So we're going to talk about how to make sure that the computer does what you want it to do. Also, we're going to cover more about data types. So I mentioned a couple data types, and I mentioned what they are, what they represent, but I want to make some points, and so that you as a programmer would know which data type to choose, because some of them sound alike, not sound alike, but kind of seem like alike. Like, for example, we're talking about decimals and doubles. Well, double can be decimal, but in which extent you use decimal, where you use double, right? And we're gonna do some enhancement to the first project, or we're gonna build a whole new project, and I'm gonna show you how those things work and uh, how to enhance it and have more fun, basically. So we're gonna start talking about tracing code. Now, tracing code is an important technique when building a program. First of all, it helps you, as I said already, to make sure that the program does what you want it to do. So, like for example, when you build a program and you end up having the wrong result, like when you solve a math problem and it seems like you found what the x is, what the y is, what the variable is equal to, but then you put that test, you put that solution in the original equation, and you find out that the answer is wrong. And then you go like, oops, where did I make a mistake? What line? Which step did I make a mistake in, right? So that leads to me saying that tracing the code also helps you to find the problem or the issue and change it, because computer reads line by line, left to right. uh, Sorry. That's why when we write the code and we go through line by line, and let's say even sometimes program can tell you which line has a problem, right? Um, so as I said, code is traced from top to bottom and from left to right. That's what I already said. Tracing helps to make sure that the program does what it should, and tracing is very helpful during debugging. Now we're gonna talk about debugging and how to use the debugger and all that stuff. Um, so basically, let me show you an example how to trace a code. So here's a coding example, right? So we have a decimal x equals to 5, right? Decimal y equals to 2.5, and then we have decimal sum, uh, you know, uh, equal to x plus y. So this is the action that the computer has to do, right? And then we have decimal z, which is a sum. So basically the answer. So as you remember from a first, class, that you have to make some space in memory to hold this stuff, right? Everything is held in memory, and then the processor actually processes whatever needs to be done, right? So you have to make a container for X. You have to make a container for Y. You have to make a container for the action. Not the container for the action. Well, yeah, container for the action where the actions are going to be stored, and you have to have a container for the response, for the result, right? For the in this example is a sum. Now I slightly changed the slide here. There used to be ints. Of course, you can say, well, 5 is an integer, right? Now 2.5 is a decimal. Now, uh, let me actually let me actually talk about this because we're going to talk about data type in the next slide. But let me talk about what's going on here. So pretty much, if you name, let's say you define 5 as an integer, and 2.5 is a decimal, right? And then the answer you think, well, 5 plus 2.5, it's going to be 7.5, so it's going to be decimal, right? So decimal sum. Now, and this is going to be decimal, right? Now, you run the program, and it gives you the problem. Now you kind of have to go through line by line and see what the problem is, right? So you start tracing from top to bottom, as I said, from left to right. So you name this one integer, this one decimal, this one decimal, and this one decimal. Now, there's some inconsistency. Now, when you run such program, it's not gonna give you the proper answer because the integer container is smaller than the decimal container. So the program will have some problems with it. So in situations like this, right? If you're doing a math operation, if you include decimals, right? You want to make sure that all your variables are named the same. Even though this is not a decimal. 5 could be, you can say 5 is an integer, right? So why should I call it a decimal? Well, you want to have the same containers. It's, um, not decimal. Sorry about that. You want to have the same size of containers. So we're going to talk about this in data type. So that way, the computer will go through and say decimal x equals to 5, decimal y equals to 2.5. So decimal sum, which is a container of type decimal, right? It's going to hold the decimal answer. So it's going to be x plus y, which is 5 plus 2.5. Decimal z would be equal to sum, right? Decimal z. So you take this and, oops, what happened? So decimal z would hold the sum. Basically, this answer would be in here. So this is about tracing. This is a simple code, but tracing, sometimes you think, I don't need tracing. I can just write a code and that's it. I don't need, well, this is a simple code. But what about this one? This one is 1, 2, 3, 4 lines code. But what if you have like 100-line code? What if you have 200 lines of code? Well, and somewhere in the line 32, you have a problem. So you have to trace. I mean, you have to learn tracing. So now we jump to data types. So I already mentioned those, let me actually make the screen bigger. It looks better. Oops, not F8, F5. Yep, there you go. Perfect. Now, so you have, let me jump back to here. So data types, right? So, so we have integers. Integer is a whole number, as you know it, right? We have floats, which is a floating point value, for example, a number with a fractional part. So, 1/2, whatever, right? So we have a double, which is pretty much like a float, but it's double precision floating point value. So it's more exact floating point value, right? You have a char, which is a character, like this is the character, right? Oops. Go back. Sorry. So this is a character, right? C is a character, H is a character, A is a character, R is a character, right? And you have a string. String is a text. So if character takes each individual thing as object, a string takes the whole line of text as an object, right? Now, as I already mentioned, all of those, 1, 2, 3, 4, 5, they have different container size. So, for example, you deal with float, double and int. Int is the smallest one, right? Double would be a bigger one. So ints cannot contain a double value, right? However, double value can contain the int value. So that's why in the problem in the slide before, I said if you deal with decimal or decimal double, right? This is a bigger container. So if you put an int is a small container. Now you add in 5 to 2.5, and it has to store 7.5 somewhere. So if you're not consistent, if you're naming 5 as an integer, the computer will not know where to put what, and will give you all this kind of instability of errors and all that stuff. It will give you problems. So better approach would be naming all your variables with the same data type. Like if you're dealing with numbers, for example, right? You name, if you're calculating something or building a calculator, adding numbers together, do it with the same data type. Don't name one as an int, the other one as a float, a third one as a decimal, and fourth one as a double. The computer would allow you to declare them like this, but then during the calculation, as I said, it will be problematic, right? One thing I didn't mention, all right, I don't remember if I mentioned that in first class, was there's a good source. It's called MSDN library. So pretty much, I would go ahead and start Visual Studio and show you. So here's a Visual Studio. If you click on Help, and let me do View Help. See, it will bring the MSDN library, pretty much, MSDN website. Now you can go ahead and search for MSDN, Google it, and type in your question inside the search field, right? So I believe this one is MSDN. Yes, Microsoft Developer Network. So pretty much, let's say you type in data types. Data types. And it'll give you a whole bunch of stuff, right? Data types, summary, visual basic, whatever, and it'll tell you the byte, the size. See, like byte is 1 byte, char is 2 bytes, date time is 8 bytes. So it gives you the container size and everything. So it's really nice. It's a really nice learning tool to use, right? In learning all this other stuff. Now another helpful website would be W3 Schools. You go here and you go on the left, and you should find a C#, CSS, JavaScript. There's a lot of stuff in here. So pretty much you can learn about some of the stuff here. But mainly I would use the MSDN library because that helps. Now, final thing, what we're gonna do today is we're gonna jump into the Visual Studio. All right, now hopefully the quality of this is better. Now I have to check if it's recording, and it does. Now, now we're gonna start. Let's start a new project. Actually, let's not enhance the old one. Let's start a new project. Now we're gonna still use the same solution if possible. No, you know what? Yeah, I'll just, hopefully it's using the same solution, but I'll just rename this one to simple calculator. So we're gonna pretty much build a small calculator. Now it's gonna do one operation, but you can change the operations around, right? Sorry about that. Oh, I didn't make sure that I select. Yeah, it's Windows Forms. So now pretty much you know the drill. We can extend it. Now first thing, I would like to rename my form. Now if you remember, there are 3 spots I have to rename. So I have to go into properties, select the form, make sure the form is selected. go to properties window and then find the text, right? And I want to say calc, right? For example, right? And then find the name of the form. So I'm looking for the name property of the form. There. Name. Give me the name property. Data. Name. And instead of saying form 1, I want to say FRM calc. FRM calc. Now, so it says calc here. FRM calc, and I change this one to FRM calc. So everything, so I can refer to it. Nope. All right, here we go. FRM calc. Yes. Okay. So now, for the calculator, we would need 2 text boxes. Now, in the first kind of tutorial, I used the text boxes and the label to display the result, right? But you can use a text box to display result too. All you have to do is just refer to it in the code, right? The text box could be the output as well. So let's just do that. So let's do 3 text boxes, right? Text box 1. Now I'm lazy. I'm just gonna copy and paste. Ha ha ha. Copy, paste, paste. So I have 3 text boxes. 1, 2. Now, for the sake of saving time, I would actually, you know what? Yes, I would use it and see how Visual Studio gives you the guides to align it. Now I would need 3 labels. So let me give you a label 1. Also copy and paste. So just 2 labels, 3 labels. And of course we would need the button, right? And the button. Button that would do the operation, right? So now we have a good habit of renaming those, right? So we go to the name. Well, since I see the text property, here's another convenient thing. If you found one property for one thing, right? So you found the text property for the labels, right? You go through and just say N1, for example, number 1, right? And then you put the semicolon, and then you jump right in, and it'll say the text for the second one. See, you don't have to go scroll down and just keep on looking on the same property, right? And then number 2, and then name this one result. So set the text to of this one to be a result, right? So now we see the text changed now. So put this on my colon. Now we go through. It might as well. We're in the same text property here. So, text box doesn't have a text, but button does. So button would be called solve, right? Okay. Okay. So now, after this, we find the property for. We can also rename those in the code. I'll show you later on how you can name the properties of those in the code. But for those of us who like using the GUI, You just go through properties window, and you find the name property for all of those because that's what you refer to in the code. Um, Name, come up, please. Don't play with me. Name. Here we go. Again, once you found the name for one, you can rename all of them. So LBL number one. Click on here. Now LBL number two, and then result. See you in LBL result. Now, when you go here, as I said, the property stays selected, and you just go through and see txt number one, txt number two, txt result, and I forgot to set the name property for the button. So I'm going back to where it says name for the button, which is right in here. It says button 1, code btn solve. Alright, now, since we have all those properties selected, again, you think, alright, so I have 3 text boxes, 3 labels. Labels are just there for, labels are just there for the appearance, right? They don't do anything. So you don't really refer to them in the code, but you want to get the habit of renaming it. It makes the code looks readable, more nice, more standard, right? So you think about it again. So I have 3 text boxes and I have a button. So I have action here, action here, action here, but what initiates the action is when I press the button. I do something, right? So I get an input, press a button, get a result, right? So I press a button, that's where the code should go. So double click a button, it creates the click event for this button, right? So this event handler is created. Again, first thing we have to declare, we have to make those containers, right? So let's say we are making a calculator that's going to deal with only integers. So this is a key. When you go through, and actually, we were talking about tracing the code. It's a good idea before you start coding, right? Before you even start coding, you take a piece of paper and you jot down the ideas for the code. Like, I want the code to do this, I want the code to do that, I want the code to do, and I want to get this result. That will help you when you debug, the code. So now, excuse me. So now, we're creating a program called calculator. So of course, we need 2 containers to store our integers. Now again, you can do doubles, you can do floats, but I just, I'm not doing universal calculator. I just want to use integers, right? So I pretty much do integer number one, num1. You can name it whatever you want, but also in the code, when you name things, you want to make sure you understand what things are. Like if I call it n1, could be name1, could be number1, could be anything else which starts with n, right? So num1, number 1, right? Integer number 1. Now you can declare things. You can say down below. You can say integer number 2, integer number 3, but you can declare things. Also, you can say int num1, num2, and num. You can put commas, right? Num3, and then put the semicolon. Now, but this would give you an extra line of code. So again, when you go back, you think about, I want to do the action right away. So now int number 1. So I want to put the integer. I want to take this integer, right? And I want to put this integer into this text box, right? I want to put an integer into text box, and I want it to be stored in memory. So this is why you created the variable to store it, right? So variable, which is of type int, number 1 would store whatever is in the text box. So it's gonna store the txt and 1 dot text. Oops. Dot text. Now you put semicolon, right? And it gives you this this red line. So it tells you something wrong, right, with this code. And there is something wrong with the code. Now you're putting an integer and you set it equal to text value. Now if you bring the mouse to the red underline, you're gonna see something like this. Gets or sets the current text in the text box. String text box text cannot implicitly convert type string to int. So it gives you the hint that you need to tell the computer that this is a number. And it can't do it automatically because computers are dumb and they don't know what one could be just a text, could be a char, or it could be an int. In this case, you wanted to use it to calculate something, right? So you want to make sure that computer understands that whatever you put in that text box is the actual number. So to do this, there are two different ways of doing this. The easiest way to remember is the keyword convert. It's the actual method, and then when you press the dot, it gives you the whole bunch of things. So convert. So we need to convert this to integer since we want this number to be the integer, right? So you find something that has to do with integer. Now you see convert to int. Now you see three different ones. Doesn't really matter which one you select. I mean, you can select to int32. Converts, and it tells you what to do. Converts the value of specific object to a 32 bits signed integer. So convert to int16, doesn't really matter, right? To int16, and then since this is what you tell them what to convert, you have to put this one in the parentheses. So this way, this line of code now, this is the variable that's going to hold our int value. Now this is where the int value is going to be taken from, right? And it's going to convert it. This is where it's going to be taken from, and it's going to convert it to integer. So the computer knows, aha, whatever is in the text box number 1 is actually integer. All right. So you do the same thing to our number 2. Int num2 equals 2. You can write down right away convert dot. Again, you can write 2, and it will tell you to int16, and what you want to convert, txt and 2 dot text, right? So you're converting text of the text box named txt.2 to integer, and you store it in the integer number 2 container, right? So now you want to go ahead and declare the result. So you say int result. That's the memory location where result is going to be stored, and then the result is going to be num1 plus num2. So now the calculation is going to be done. Now you don't have to actually declare another, as I showed you in the code, you don't have to declare another variable to store the result. All you can do is, now that you know that the result is going to contain the answer to this problem, right? To this problem, all you do is you set the third text box, which is the result, right? In our code, we'll go to design view. In the result, you want to set the text of this text box to be showing the result, right? So you do 60 result dot text. You send the text property of that equals to result. Now the computer is going to give you the problem again, and this is again the conversion problem. See, it says cannot implicitly convert type int to string. Now whatever you display is not the integer anymore, it's considered a string. You display the string of text, whatever it is, a text, chars, ints, doubles, whatever it is. You want the computer to put it out as text, right? You want the computer to print it out. So you do the opposite action here. You convert this to string. It tells you where to convert it to, right? You need to convert this to string. So you use the convert to string Let's see if it's gonna work. If not, I'll make sure that I put it in the right location. And you want to convert to string with the result. And voila. Now, since you wrote the code, you want to start the program, right, to test the result now. So the computer's going to run, and you input number 1, input number 2, and you press the action, solve, and it's going to display 5. Right? So you see the program is completely working fine. Now, this field right here, the label field is not editable. So whatever it displays, it displays. This field is editable. Look, 6 or 7. You can set the property of this field to be locked down so that people cannot edit. So to do this, you stop the program, you go back into designer view, you click on that text box, and you go to property window, and you need to set a property visible to false. I think that's it. Let me check. I think that's it. So when I run the program, yeah, you can do that. You can do visible, but let me make sure that the program works. I think it's it's not visible. It's one of those properties. I don't remember which one offhand, but let me see. Let me set this back to true. Would wrap read only. There. True. Read only is true, right? So when you set it to read only, it's going to be grayed out. When you run the program, right? So now let's see. 2 plus 3 equals 5, and you will not be able to change it. Whatever you do, you will not be able to overwrite this value. So there you go. We created a calculator, that is able to calculate integers. Now, this calculator might need some work to be able to calculate negative integers. You have to put some boundaries. You have to make sure that the program knows from where to where it's gonna calculate. In order to calculate doubles or decimals, well, the answer to that from our today's class, all you need to do is actually change the container type or data type to decimals. And now, when you change it, let me actually do this. So you change this one to decimal. You change this one to decimal, as you have to be consistent. Let me actually show you what happens when you don't do this, right? When you actually leave the int result, for example, as integer, and then you need to convert this to decimal. You can't convert this to integer since you're getting the decimal. So you have to say convert dot to decimal. And here to decimal. Now it's gonna complain saying decimal, thinking up implicitly convert from into decimal to integer, so it already complains. So you know something is wrong. Then you have to actually you have to work on here and fix the problem, like, right? So let me undo all those changes. And I'll show you way number 2 to declare this, right? I'll show you way number 2 to convert. Another way to convert, as I said, this is one of the ways to convert, right? Another way to convert would be using dot parse. So all you do is instead of saying convert to integer, use this. Right? So you can use integer dot parse, and here you can say integer dot parse. Parse is the same thing. It just has to, you don't have to write convert dot to integer. Just int dot parse, and you can leave this one convert, and I'm pretty sure it's gonna work. Let's try it out. Or you can change it to dot parse. Doesn't really matter. Yeah, the program builds with no problem. So 3 plus, it doesn't give any issues, but you know, it's a good habit to actually name, use the same method. I mean, then you can trace it. Again, going back, when you trace it, it's gonna make your life easier. So dot parse, okay, this is parsed correctly, this is parsed correctly, convert that, and use, So if we can choose which one you use ahead of time, and you can just stick with it. Like if you use convert dot, or you can use int dot parse or string dot parse or char dot parse, whatever dot parse. You can use that or the other one, but it's good to be consistent. Then the code is more readable. So pretty much this concludes today's lesson, guys. Thank you for tuning in and thank you for watching it. And hopefully, those lessons are helpful to someone and you guys are able to actually write your own simple programs. You can try writing the program and let me know how you done, how you did, and if it works. Unfortunately, you would have to either download a trial version of Visual Studio or purchase Visual Studio if you want to actually, if you want to actually work with Visual Studio, and work with me, work with, do the exercises along with us. Anyways, thanks guys for watching. This was Stanny G Tech, and I'm signing out. Peace. Thank you.